topic modern physics, and in this section I'll be showing you how to convert energy to mass, mass to energy, and also units of mass to other units of mass, and units of energy to other units of energy. Now, I will be using the terms mass and matter somewhat interchangeably. Mass is actually a measure of the quantity of matter that you have. But again, I will be using the term mass and the term matter somewhat interchangeably as if they were synonyms. Now, the first unit that I'd like to introduce is a unit that we actually saw for the first time in chemistry. In chemistry, the unit is called the atomic mass unit. The atomic mass unit. In physics, the same unit is called the universal mass unit. I really wish that they would get together and just make up one name or agree to call it by one name. I've taught both chemistry and physics. This is annoying. They should come up with one name. But in any case, you saw this unit in chemistry. Here we see the unit again with a slightly different name in physics. Note what they both have in common. It is a unit of mass. A tiny, tiny, tiny unit of mass. Now, it would be really nice to be able to convert mass into energy. And we can do it to some extent. We can't quite control it as much as we would like to, but we can do it to some extent. Perhaps you've seen the wishful thinking on an old television series called Star Trek. Or maybe you saw the new Star Trek movie, which was actually pretty good. What they do in this TV series and in the movie is that a spaceship, in Star Trek language we call it a starship, is orbiting around the planet of the week. And the people on the ship have to get down to the planet on a somewhat hourly basis to solve all the problems that they're causing. Well, how can a person orbiting on a spaceship, oh my goodness, we're not doing such a good job here of drawing the spaceship. Here's the spaceship orbiting the planet, all right, going around and around and around the planet. And the people on the spaceship have to get down to the planet. Well, what they do is they use a device called a transporter. And theoretically, what the transporter is able to do is you stand in the transporter, you're made out of matter, the transporter converts you into energy, beams you down to the planet, and then reconverts you back into matter, hopefully in exactly the same shape as you were when you started up on the ship. So you're actually converted from matter to energy, beamed down to the planet, and then converted from energy back to matter. Again, this is all theoretical, and fortunately, we can't do this yet. All right. Now, under what circumstances is matter actually converted into energy in our day-to-day life? In a nuclear reactor, whether it be a fusion reactor, which uses uranium as a fuel, or a theoretical fission reactor. We don't have working fission reactors yet, not that we can get electricity to light up a city with. But in both of those nuclear reactions, a tiny little bit of matter, a tiny little bit of mass, is converted to energy. Lots and lots and lots of energy. So this is where we see matter converted to energy in our daily life. There are some cities in the country, in the world, especially in France, that are powered largely by the presence of a nuclear reactor. All right, without getting into all the pros and cons about nuclear reactor, a nuclear reactor converts a little bit of mass into a lot of energy. So now let's talk about converting, about the units involved and converting mass to energy, energy to mass, and some of the interconversions, certain units of mass to other units of mass, certain units of energy to other units of energy. All right, so getting back to our friend here, the atomic mass unit. All right, what exactly is a universal mass unit? He's right on the front of the reference tables. One universal mass unit. All right, one, I'm just copying from the front page of the reference tables. One universal mass unit. And right across from that is exactly how many energy units the universal mass unit is equal to. 9.31 times 10 to the second mega electron volts. That's mega electron volts. Now, this means that we can use this conversion, all right, this conversion factor here, to convert directly from universal mass units to mega electron volts. So, let's take, for example, 0.2. Now, the symbol for universal mass unit is mu. Again, mu. We've seen mu before, coefficient of friction. The muon has this symbol, but here it's symbolizing a universal mass unit. I want to convert this to mega electron volts. Again, this is a unit of mass. My mega electron volt is a unit of energy. So by using this equality, I am converting from mass to energy, from matter to energy. All right, here we go. I want to get rid of the mu, and I want mega electron volts. I look on the front of the reference tables and I see, now please remember, put your units in correctly first, then worry about the numbers. I want to get rid of this, so I put it down here. They're going to cancel. And what I want, I put up here. Now, from the front of the reference table, one universal mass unit is equal to 9.31 times 10 to the second mega electron volts. All right, so let's do that on the calculator and see what we get. All right, 0.2 times 9.31 second E 2. All right, I'm getting 186.2 mega electron volts. So I've just converted matter to energy. A unit of matter to its equivalent amount of energy in an energy unit. All right. Now, what exactly is a mega electron volt? Let's look at that unit of energy now. Now, I know you've heard of electron volts before, but what's a mega electron volt? Let's check that out. Now, on the front of your reference tables, front page, lower left corner, there's a chart of prefixes. And if you look up mega, capital M, it means 10 to the 6th. All right, so mega, abbreviated capital M, means 10 to the 6th. And 10 to the 6th, 1 times 10 to the 6th is, all right, here's my decimal, 1, 2, 3, 4, 5, 6. 10 to the 6th is, right, how much? How much is 10 to the 6th? It's 1 million. So mega means a million. Right now, does a mega electron volt sound to you like a big unit or a little tiny unit? If you said that mega electron volt sounds like a big unit, you're correct. 1 mega electron volt is 1 million little electron volts. Or write it this way. 1 mega electron volt is 1 million little electron volts. So what I'd like to do now is convert my 1 universal mass unit and my 0.2 universal mass units to electron volts. All right, let's remember what we had there before. We wrote down before, and let's see how much we can keep up on the board. I hope we can keep some of this up on the board. 1 universal mass unit is equal to 9.31 times 10 to the second mega electron volts. And 0.2 universal mass units was equal to 186.2 mega electron volts. Now let's convert this to electron volts. All right, 9.31 times 10 to the second mega electron volts. I want to convert that to electron volts. I want to get rid of mega electron volts. I want electron volts. 1 big giant mega electron volt is equal to 1,000,000 electron volts. Let's do that conversion, and let's do this conversion. 186.2 mega electron volts, right? Get rid of mega electron volts, make them cancel, put electron volts on top. 1 mega electron volt is equal to 1 times 10 to the 6th electron volts. Okay, so what are we getting here? Let's do the math. 9.31 second E2 times 1 second E6. All right? And we're getting 9.31 times 10 to the, I'm going to count the spaces, 1, 2, 3, 4, 5, 6, 7, 8. All right, times 10 to the 8th electron volts. The mega electron volts cancel. This one here, 186.2 times 1 second exponent, all right, 1.862 times 10 to the 8th, 1, 2, 3, 4, 5, 6, 7, 8, times 10 to the 8th electron volts. Okay, so I have discovered by converting mega electron volts to electron volts that, first of all, 1 universal mass unit is this many mega electron volts. That's right on the front of the reference tables. And how many electron volts is that? 9.31 times 10 to the 8th electron volts. All right, and this one here is equal to 1.862 times 10 to the 8th electron volts. All right, now, on the front of the reference tables, there's also a way to convert electron volts to joules. They're both units of energy. We're converting from one unit of energy to another unit of energy. All right, so on the front of the reference tables, now I'm going to take this, right, 9.31 times 10 to the 8th electron volts, and I'm going to convert it to joules. It's on the front of the reference tables. I'll show you in just a moment. I'm also going to take this one and convert it to joules. All right, all I'm doing is converting electron volts to joules. Now, right about here, all right, near the bottom of the chart on top of constants, near the bottom, 1 electron volt equals 1.6 times 10 to the negative 19 joules. Whatever's on this side equals what's on this side. All right, so I want to get rid of electron volts. Electron volts on top, get rid of them by putting electron volts on the bottom. I want joules. It says 1 electron volt equals, it says 1.6 times 10 to the negative 19 joules. Okay? All I want to get rid of electron volts. I want joules. 1 electron volt, 1.6 times 10 to the negative 19 joules. Let's do the math and see what we get here. 9.31 second E 8 times 1.6 second E negative 19. I'm getting 1.49, I'm rounding off, times 10 to the negative 10 joules. Over here, 1.862 second E 8 times 1.6 second E negative 19. I'm getting 2.98 times 10 to the negative 11 joules. All right? So, okay, I'm just double checking. I did some of this math before. These are all correct. Like I pressed the right numbers. Oh my goodness. All right. So, we now know that 1 universal mass unit is the same as this many mega electron volts, which is the same as this many electron volts, which is the same as 1.49 times 10 to the negative 10 joules. And 0.2 universal mass units is the same as this many mega electron volts, which is the same as this many electron volts, which is the same as 2.98 times 10 to the negative 11 joules. Okay, now, the moment you've all been waiting for. Now we want to convert energy to mass. And there is an equation for that, to convert energy to mass. You know it. E equals mc squared. Where does that equation appear on our reference tables? It's on the page called Waves and Optics. Right, waves, and underneath that, modern physics, that's where you find E equals mc squared. But I don't think you're going to forget this one. What does this equation do? It converts kilograms to joules. You can only put kilograms into this equation. You only get joules out. In other words, you cannot put electron volts into this equation, at least not in Regents Physics. There are conversion factors in other physics courses where you could possibly put electron volts in here, but for Regents Physics, you can only put kilograms in here, and you can only get joules out here. Or you put joules in here, and you get kilograms. Kilograms and joules, because c, the speed of light, which we use, is going to be in meters per second. That's going to go with kilograms, and it's already in the joules. Okay, so matter to energy, energy to matter. All right? Let's take the joules, put them in here, and find out how many kilograms that would be equal to. All right, here we go. Now, I have joules, E. I want M, matter, kilograms. So, let's rearrange the equation. E equals mc squared would be M equals E over c squared. Students, be very, very careful when you rearrange equations. All right, what I would do, you want to get the M by itself, divide both sides by c squared. Those cancel. All right, M equals E over c squared. Okay, that's the correct equation. Don't come up with some ridiculous form that's not correct. You'll get the wrong answer. All right, so M equals E over c squared. All right, here we go. We have E, 1.49 times 10 to the negative 10 joules. Now, c, the speed of light, is on the front of your reference tables. It's a constant. It does not change as long as that light is going through a vacuum or of space or air. Speed of light in a vacuum, 3.00 times 10 to the 8th. Now watch. Make sure you put this in parentheses and square it. Okay, 3 times 10 to the 8th meters per second. Most common mistake is to forget to square this. All right, so here we go. 1.49 second E negative 10 divided by, open parentheses, 3 second E, you don't put in 3.00, just put in 3, second E 8, all right, square it, close the parentheses, or close the parentheses and square it, either way, and you're getting 1.66 times 10 to the negative 27 kilograms. All right, that's how much matter you would convert into this much energy. And if you could convert the energy back to matter, this is how much matter you would get. That's how many kilograms. I put in joules, I get out kilograms. All right, let's do this one over here. You know what? Let's just do it without writing it. 2.98, right? The energy divided by c squared. 2.98 second E negative 11 divided by, open my parentheses, 3 second E 8, square it, close the parentheses, and I get, looks to be the correct answer, 3.31 times 10 to the negative 28 kilograms. All right, is that correct? You know what? I'm going to double check that because that doesn't look right to me. All right, hang on one second. 2.98 second E negative 11 divided by, open the parentheses, 3 second E 8, square that, close the parentheses. Okay, we're getting it. All right, 3.31 times 10 to the negative 28 kilograms. Okay, now let me show you something really nifty. All right, so this is 1 universal mass unit is equal to 1.66 times 10 to the negative 27 kilograms. Up here, 0.2 universal mass units is equal to 3.31 times 10 to the negative 28 kilograms. All right? Just take 0.2 of this to see if we get that. Let's do that as a double check. You know what? Let's double check this, all right? Let me multiply this by 0.2, see if we get that, okay? Because that's 0.2 universal mass units. 1.66 second E negative 27 times 0.2. Okay, we got it. Fine. All right, we double checked it, so that's correct. All right. Now, I told you I was going to show you something neat. All right? 1 universal mass unit. We converted to mega electron volts, converted to electron volts, converted to joules, finally got to kilograms. So this is how many kilograms there are in 1 universal mass unit. But have you seen this number before? Have you seen this number before? Where have you seen this number before? In the front of the reference tables. The rest mass of a proton down at the bottom of the top box, the rest mass of the proton, the rest mass of the neutron is listed as 1.67 times 10 to the negative 27 kilograms. So, 1 universal mass unit is approximately, almost exactly, the mass of 1 proton or 1 neutron. That's what a universal mass unit is, approximately. I think it would be a good idea to memorize that 1 universal mass unit is approximately the mass of a proton or neutron, which is listed on the front of the reference tables. All right? Okay, we've done a lot of converting here. Now, this is a unit of matter. This is a unit of energy. We can convert from matter to energy using the front of the reference tables because it says how many universal mass units are equal to how many mega electron volts. So we can do this without an equation. We can convert mega electron volts to electron volts because we know what mega is. Mega is 1,000,000. The mega electron volt is a big guy, so 1 mega electron volt is 1,000,000 little electron volts. We can do that conversion. That's energy to energy. So matter to energy, energy to energy. Now, we can go from electron volts to joules, because on the front of the reference tables it says that 1 electron volt is however many joules, 1.6 times 10 to the negative 19 joules. That's energy to energy. And then finally, using the equation E equals mc squared, we can convert from energy to matter, from joules to kilograms. We did it over here. We did it over here with a slightly different quantity of universal mass units. All right? So, is there anything else that we'd like to say? No, yeah, there is one other thing I would like to say. This method of converting that I'm showing you with the big parentheses is called the factor label method. The factor label method. We don't care why it's called that. The bottom line is that this method of converting you will use, you can use, and you will use, whether you become an engineer, a doctor, a nurse practitioner, a pharmacist, an architect, any of those professions where people's lives are at stake based upon the conversions that you do. How is the factor label method used? If you know, for example, that one whatever, let's say let's do mega electron volts. 1 mega electron volt is equal to 1,000,000 electron volts. Now let's say I have 50 electron volts, and I want to know how many mega electron volts that is. What if I have 5 mega electron volts? 5 mega electron volts, and I want to know how many electron volts that is. If you have an equality, two things that equal each other, you can convert these to these or these to these using the factor label method. Now, people get confused, so please listen very carefully to the instructions. You have electron volts. You want to get rid of electron volts. So you put electron volts on the bottom. They will cancel. Don't worry about the numbers until you got the units in the right places. You get rid of the electron volts, you want mega electron volts. Now worry about the numbers. 1 big giant mega electron volt is equal to 1,000,000 little electron volts. Now, you don't cross multiply because the equal sign's over here. If it's on the top, you multiply 50 times 1. You know you don't have to do that. If it's on the bottom, you divide. So this would be 50 divided by 1,000,000. All right, 50 divided by 1 second E6 equals 5 times 10 to the negative 5. Those canceled, and I get mega electron volts. All right, now, the other way to go from mega electron volts to electron volts. I have these. I want to get rid of them. Put mega electron, same thing on the bottom. Those are going to cancel. Trying to get rid of mega electron volts, right? All right, I want electron volts. So 1 big giant mega electron volt is equal to 1,000,000. All right, now here, let me just put the wrong things in there for just a second so you can see how you can easily fix this. If you do it like that, which is wrong, you say to yourself, 1,000,000 big giant mega guys is equal to 1 little guy? I don't think so. This is wrong. I've got the wrong numbers in here. It's going to come out wrong. The answer will be wrong. All right, so think about how many electron volts and how many mega electron volts. One big guy is equal to 1 times 10, a million little guys. All right, you have to have some sense of which unit is larger. The mega guy is larger. All right, now, again, you don't cross multiply. The equal sign is over here. To cross multiply, the equal sign would have to be in the middle. It's not. All right, you don't cross multiply. It's this times this. Whatever's on the bottom, you divide by. Whatever's on the top, you multiply by. There's nothing down here but a 1. You don't divide by 1, you get the same answer. So 5 times 1 second E6 equals 5 times 10 to the 6th electron volts. The mega electron volts canceled, and I get electron volts. All right? That's the factor label method. There's an entire section on the factor label method. I just wanted to show you, just in case you were confused by some of the conversions that I was doing. If necessary, watch the whole video, this section all over again. All right, now that we've done a little review of factor label method. And there is a whole video on factor label method if you want to go look at that video. I will see you in the next section.